Example 14.10 part B gives us a new function. This is function h, and h is already in factored form. So that's going to make finding the zeros very easy for those that want to do that calculation. The end behavior, however, you have to make sure that you put your equation into standard form before you start thinking about what the end behavior really is. So let me give you the information that we need. The end behavior is where we'll start. So for that end behavior, I want to be sure that I look at the standard form for this. So the standard form for this is going to end up having negative 2x to the 6th as the leading term. So that gives me a degree 6 that's even, gives me a leading coefficient that's negative. So I'm not actually doing the full multiply out to get the standard form, but this is what that leading term would look like if we did that. So from there, I can tell you that y will approach negative infinity as x approaches infinity, and then y approaches negative infinity as well as x approaches negative infinity. For your x-intercept calculation, you will get 3 x-intercepts, the origin, 1, 0, as well as negative 5, 0. And the multiplicities on these can be seen relatively quickly from the factored form, which was originally given to us. So we have a multiplicity of 3 at the origin, multiplicity of 2 at positive 1, and then just a multiplicity of 1 at negative 5. Your y-intercept is also going to be the origin, not really much of a surprise there, and then the symmetry on this particular function there is no symmetry, so I'll just write none for that. So starting with the points like we did with example A, we'll have a point at the origin, a point at 1, 0, a point at negative 5, 0. The y-intercept doesn't give us anything else new. The end behavior, however, both the right and the left arrows are going to be going down. So when I put the arrows on my graph, I don't have to put them all the way into the corners of the window. I want to put them down toward the bottom because they're supposed to approach negative infinity, but I want to put them just a little bit to the right of the last x-intercept on the right and a little bit to the left of the respective x-intercept that's on the left. So this gives me a nice little interval here to think about where my graph is going to be located. Starting with the left end behavior, I will start going up until I get to the x-intercept at negative 5, which we should see has a multiplicity of 1. That means I just need to cross through the x-axis there. Then I want to get over here to the origin, so I'm going to increase for a little bit longer, then I'm going to make a nice smooth turn and start heading down toward the origin. Now at the origin, we have a multiplicity of 3. With multiplicity of 3, we have to cross the x-axis, but we have to do so while we flatten. So there's one of two ways that will look. It'll flatten and cross, or it might flatten this way and cross. So wherever you're at in your graphing process will dictate which one of these two you're supposed to use. So based on what we see here, that first version of the flattening and cross is what we need. So I'm going to go ahead and draw that flatten and cross at the origin, and then I can go ahead and connect the rest of the second quadrant here. And now I'm in the fourth quadrant where I have really the rest of the information is here. I have the x-intercept at 1, and then I also have my end behavior going down in this quadrant. Now thankfully we have a multiplicity of 2 at 1, and we talked about the multiplicity of 2 in the last example, so this is going to create a relative extrema, specifically a little relative maximum there. So I know it's a really quick turnaround, but we're going to very quickly make a smooth turn to connect from the origin to the x-intercept there at 1, And now I'm set up perfectly just to continue going down until I reach my end behavior. So maybe I need to move my end behavior over just a smidge. And there's nothing wrong with that. If you use pencil, then you can always erase and make adjustments as needed. And this should give us the graph of H.